this is buffer problem set 2A. The one requirement is that you have completed all the problem 1s because you are going to need some of that information to do the problem 2s. So basically in problem 2, it's telling me I'm adding 0.020 moles of HCl into each of these 4 solutions. So the first one I'm looking at is the propanoic acid one. So if I add propanoic acid and HCl together, the HCl is definitely going to react with the propanoate ion. So I'm adding H plus to the solution, and I'm going to react it with the C3H5O2 minus. I know that because I can't have the H plus reacting with propanoic acid. There's nowhere for it to go. But if it reacts with this part of it, then it will definitely make propanoic acid. So now, I'm actually just going to flip this for ease because it's way easier if I'm dealing with the Ka, which I know and love. So if I flip this around, which really doesn't matter because it is in equilibrium and it won't make a difference. This should be an equation that you're super familiar with. It is the same as the other equations except there's no water, which is fine. So now what I need to do is calculate my initial concentrations. Well, I know I had 0.1 molar propanoic acid, and it just says I add moles of 1 liter of each of the following. So initially, I have 0.1 molar propanoic acid. They tell me that, and I'm not actually adding any propanoic acid. I am, however, adding some H plus. So instead of starting with 0, I'm starting with 0.02. Now, how did I get that? So H plus, to calculate concentration, it's going to be moles. So 0.020 moles divided by how many liters of solution? Well, it says 1 liter of solution. So simply put, I have 0.02 molar. And I don't have any propanoate right now. I do think, however, it is going to go this way because I don't have any propanoate to make it go that way. So my change is going to be minus x, and plus x. So I have 0.1 minus x, 0.02 plus x, and x right here. So let's look at what I get when I plug this into Ka. My Ka equals, well, I'm going to use the same Ka from problem number 1, because that's what I'm looking at, 1.3 times 10 to the negative 5, H plus C3H5O2 minus, and that's all over HC3H5O2. Plugging that in, I get 0.02 plus x, and 0.1 minus x. Again, I could probably ignore the x's. We're going to have to check, but for now that should be fine. So if I'm looking at this, I have these two x's ignored and this x stays. So let's see what I get. 1.3 times 10 to the negative 5 times 0.1 is 1.3 times 10 to the negative 6. And I'm going to get equals 0.02x. Divide each side by 0.02. Put it in your calculator. Don't be lazy and make me do it. I get, and hopefully you get the same, 6.5 times 10 to the negative 5. But here's my problem. I don't get that this is the concentration of H+. It's not. H+ is 0.02 plus this number. So H+ equals 0.02 plus 6.5 times 10 to the negative 5th. So why don't you add that right now? And you should get 0.02065, which makes total sense. And the units are molarity. Now, if I wanted to find out the pH, I would simply take the negative log of that answer, and you can put that in your calculator right now. And for my pH, I get that the pH is 1.70 once I round. Now, I know that that is compared to my original pH, which I believe was about 4.89 from problem 1A. So 1A had a pH of 4.89. When I add this much acid, it really lowers the pH. So just as a commentary, this really didn't help me. And the thing was, it's not a buffer system, so I wouldn't expect it to.